Well, I think Tejas has done a very good job in introducing me, and I feel he's already given the talk that I was supposed to give, like in a second. But yeah, I'll try to add on more details to it. Before that, a little bit about me. I started my career as a boring backend developer working for a Swiss bank. And you're currently listening to someone who loves making kombuchas, so I would like that to be my personality. That is the major thing about me. But other than that, I am a developer advocate at SurialDB, as Tejas mentioned, and I am a backend developer. What I am not is actually a JavaScript developer. So please be kind to me if I end up saying something completely wrong, and please feel free to educate me at right this moment, because since the time I've been here, one thing I've realized that the community is amazing, and it's been very welcoming, and I hope to be at more JavaScript conferences for sure. So a little bit of TMI about me. I have very sensitive skin, and any time when I wear something that is a bit like a new material or something that does not belong to me, I start having like a red skin and skin rashes. So what I normally do is like I go to a cafe and I just scream it out to people like, I have a rash, and why do I have it? That's what I do. Does anybody else do that? I mean, I'm kidding, actually. Like, I don't literally go to a cafe, but I do something similar to that. Like, I ask on Google. But I guess when I'm sharing something about my medical issues or something like even information that's very sensitive and private about me on Google, or, for example, what we currently use is most of these AI tools, don't you think that's the same thing that we're doing? We're basically sharing information to the cloud, and we're sharing it with like a bunch of people sitting in a cafe. That's literally what we're doing. Now, yes, there's tech, abstractions involved in the middle, but over the couple of years, we've seen that there have been a lot of privacy issues that have come up with when you're sending your sensitive data to AI. And why is this? Like, why does this happen? Now, this is not me. This data is from a very well-known AI incident database. You should all check it out. It talks about all privacy or all AI-related issues that are currently happening. There's a lot of issues around what happened with Taylor Swift and how her identity was stolen, and a lot of creepy, weird things. But these are some of the major ones that we might have all heard that was shared by like Forbes and New York Times and the major leading articles about how data is not safe. Now, data was never safe since the moment the word cloud came in. We all know that, but we decide to go ahead and make our decisions and make our choices. The end goal about this, like, as long as it's something that does not affect us, I feel it's fine, because AI is something that is going to be a part of our lives ahead every time, and it's fine as long as you know how the AI can unlearn your data. Like, where is the delete button for your data? Cool, I'm sharing these pictures, and AI is going to learn, it's going to build over it. But what if I don't want it to learn? What if I'm done using it, I want it to like forget me? Will AI actually forget you? I am not sure about that. Based on the research that I have done, there is some work happening in this domain. Like there is a lot of work where researchers are trying to help AI unlearn your data for specific use cases. But while machine learning experts are doing their thing, what we can do on a small scale is push some of our daily applications to a local format, to using an application which does not require access to internet, and making sure that it is built only for your use case. It is just your tiny pet that will follow you along and help you with whatever you need. Now, it won't be the best application, it won't be the most fastest, but it will do the job for you, and you'll feel safe about some things that you don't want to go out. Some good examples about this is we do keep changing a lot of jobs, right? And we do get a new agreement, a contract for all of these jobs. Now, they are really lengthy, and I completely do not understand the jargon. But imagine like having a personal application, AI application, that will help you understand your contract help you understand the red flags of it. And similarly, an AI tool which helps you track the family history, the family medical issues, tools which are needed, but you're not really okay with that data going out or like people training on this sensitive data of yours. These are some good tools that are okay to have less processing power, to be a bit slower, but to have them on a local side. In this talk, I'm going to be using a couple of jargons. Feel free to ask me later about any of these jargons, but I'm pretty sure, like, with so much talks about AI, these are all well known. But to condense it down, what we're specifically going to talk about today is what is a good local tech stack to build applications locally. Now, these are not the only tools available. There are some amazing tools out there, and they are actually way more easier than these bare-bone tools. But this is the tech stack that I chose because this helped me get deeper into the understanding things, how they're happening on the hood. There are amazing APIs that were suggested to me that you can just directly pull, and there are drag and drop applications that could help you build similar tools, but that's not the focus of today. Today, we are going to focus on 3 major paths that work under the hood after you put in a query in an AI application. What is the first thing that the query, where is the first thing the query reaches? Then how does it understand context? Like, how does it pull information from? Where does the model come in? And blah, and blah, blah. So the first component of today is Ollama. Now, a good introduction to Ollama was a single line definition to Ollama was given by my new friend, David, that I met at a nearby cafe near the hotel. And I remember we all were sitting there, and there was no Wi-Fi. And there was Kevin with us. I don't know if they're in the audience. But all of them were struggling to work because there was no Wi-Fi. And David was like, I'm using Ollama. I don't need Wi-Fi. And it was the coolest thing ever. Like that, I don't think there's a better way anyone has ever sold Ollama. So yeah, the whole selling point and the gist of Ollama is that it's a local open source, it's an open source tool that can help you build locally your applications, and all the models are saved on your local hardware. Now, it has its restrictions, like you won't have the same speed as any AI API that you're pulling from the web, but as I'd mentioned, it has one of the best developer experiences out there. And to sum up, what Ollama basically does, it helps you to download these models, and that is the one time it does need access to internet. Like when you're first installing Ollama and you have it on your machine, to download all the models, it does require internet. It also runs on most of the devices out there. It runs on Linux, MacBook, and Windows. You would also need internet if you want to push a model to Ollama. And finally, it gives access to multiple APIs, due to which you don't have to understand what's happening in the black box of Ollama, and you can directly use the APIs. The cool thing about it is from the UI, you could literally test a single question and query and see how the particular model does. So to go a bit more deeper, we are going to check one particular flow chart of how does Ollama work. So if this isn't very visible, let's go ahead and zoom in. This magic is done by Tejas. So yeah, so when a user is asking for a model, Ollama basically first checks if it is available locally or if it's not. And that's when I said needing Wi-Fi is needing internet access is when it is not available locally. You would then download the model from internet, or if not, if it's available on your device, it will do some computations on these models. The reason is because Ollama will run on your Mac. Ollama will run on a very simple machine also. So for this, it needs to compress the model. It needs to make some changes to the actual size and precision of the model. And that's where you won't get the fastest, the best result, but it does the job. And it is something that should, if you support it with more machines or in a better way, it should do the job very well for you. And yeah, as I mentioned, it also helps you to create APIs, and then it's ready to answer your questions. So just summing it again, the Ollama is completely local, except the following use cases, which is when you want to download a remote, when you want to download a model, or if Ollama is sitting on a remote server, and basically when you want to upload a model. So these are the 3 cases when you would need access to internet. And now we're going to see the demo of my favorite model from Ollama, which is Moondream. I really love it because it's very tiny, and like compared to others, it's very fast, and it's fun. Like, for me, this model is the definition of a to-do app that should introduce you on how to use different models, and this specifically is a vision model. So let's try it out. Let me just increase the font. Of course, you're going to see all the errors that I had before. So this is the complete piece of code that you would require to use Moondream on, like, in the core sense. Here you're importing Ollama from the community package. You also have the image which you're going to pull from anywhere on your file. Like for me, it's sitting in my photos file. And you could either use a base URL or any URL that you're planning to. The one thing you need to notice is that you do have to convert it into a base 64 string so that it can, the model can understand it. And finally, you can invoke the model and ask it a question. So I am going to run this again. OK, I'm just going to be careful, yeah, because this keeps happening with me. Just a minute. Yeah. So I've already asked this question, OK? So I've hard-coded the question, which is what's in this image, and I've given it an image. Now, let's see what the description says, and then we'll go to the image and check if it's the same description. I could literally add any image here, and I've not hacked this demo. If you have any requests, I can add another image. But it's saying that the image features a woman standing on the deck of a boat, posing for a picture. She's wearing a white dress. Her long hair flows down her back. The boat she stands on is adorned with a blue railing, blah, blah, blah. So let's go and check my photos folder, and let's see if that image is there. So yeah, these are you getting a peek into my. But yeah, that's me in front of the Tower Bridge, not the London Bridge. I know that. So this is the image address that I'd given, and it has pretty much defined it very well. So you could add in more details. You could make sure that you have an output that you're happy with. But this is as simple as it can get to run the Moondream model. Coming back. So this is not the end. I know you're hungry, but there's a little bit more left. So this was just one model that we saw. There are, in the demo that a short demo that we're seeing today, we're using a chat model also. We're using an embeddings model also. And of course, we're using the Moondream model. So this is how you would initialize any model via Ollama. It's pretty well maintained. Now that you have this data from your models, how and where do you store it? Can anybody give me an idea? Where would you store this? In what format? Cool, we don't have time, and I'm going to rush. So you save this data majorly in a format which is known as vector embeddings. So I feel vector embeddings is just a fancy word that VCs have created. But it's nothing. It's just an array where you're putting your vector data. That's all vector embeddings are. And yeah, a little bit information about them, that they can be multidimensional, and they're intended to capture the semantic meaning. It's intended to capture more than the normal full text search could help you capture for any of your data, like more than text. This is how. So for this demo, I am using SerialDB, which is a multi-model database, and it also has embeddings involved in it. So I am using this database because I don't want to use multiple databases for different things, like not a vector DB differently, not a Postgres one, blah, blah, blah. I want my metadata along with my embeddings. So this is how you would specifically save your metadata about something along with the embeddings in a SerialDB record. But that's not something that we're here for. Now, what do you do with all these vector embeddings? And how do they help you get to your answer? So what happens is these vector embeddings are then stored into a magical box that's known as vector store. When I was back in college and school, I had this librarian who, whenever I used to talk to her, I knew what I wanted, but I just didn't know exactly what I wanted. And I would tell her something like, you know what, I need this book from Nancy Drew, and it needs to be about adventure, but I don't want it to be like, I don't want it to have a romance angle. It just needs to be about Nancy Drew and adventure. And she would know exactly what book to pick up for me. And that's literally what a vector store is. If I were to define vector store, it's that smart librarian that knows what to pull for you and where to store something when it comes to your vector data or your vector embeddings. And it does more than that. Like, my librarian would know where to keep the book that I'm giving her. Like, she had it all mentally mapped. So that's, again, what a vector store does. It has a complete mental map about what you want to do with your vector embeddings and what different functions you could do on your vector embeddings. So coming back, a vector store it stores and retrieves vector embeddings. It includes functions for performing similarity searches. And finally, it also helps you with indexing data. Now, two words that I've used here is similarity searches and indexing data. A quick deep dive into this vector search domain. I would rather like to show you what vector search is. Has anyone here worked with vector search before? That's amazing. That's good to know. So on the bigger terms, it's very similar to what full text search is. But again, as we had seen, vector search helps you remove more meaning from your data. It goes deeper. It helps you have semantic understanding of something. It's very well used in text embeddings or image processing, and that's where like your Google Lens and all these applications have vector search working around it. Let's see how vector search work under the hood. So this is the bare minimum queries that I'm showing you. Like, these are literally the database queries that run when vector search happens. For anyone who's wondering what this complete setup is, it's the Surrealist dashboard that comes along with SurrealDB to run and test your queries. So I've just created a table which is a schema-less now. So I'm going to run this table, and we have the table created. Next up, I'm going to insert some data into this table. So this array this array that you see, this could basically be your embedding. That is how your embeddings on a bigger scale would look like. These are like pretty baby data that I've input, but it's just for demo purpose. So we are inserting some items into the record. Oof, of course, something has to not work. Let's see what went wrong. Come on. Oh, cool. So yeah. So this is, I don't know, man. Like, every time you folks clap, I feel like you want me to finish. But there's just like last bit available, but yeah. Thank you so much. This is basically inserting some data into the record, and finally, we're going to do something very cool. We're going to create an index. Now, this is a vector index. That is what, until now, it was just a record, it was just data. But the moment a vector index comes into picture, that's when it knows, OK, now I can perform different vector searches on it. Now, there are a lot of different models, like vector embedding, like ANN, HNSW. These are terms which are used when you're trying to build vector search. This isn't something that normal people should know. I wouldn't if I could. But let's define an index that should help us do the vector search. And if you see, this emtree is it's a kind of a way how you want your data to be indexed. You could also have HNSW, or you could just use a brute force method. So we have defined an index, and finally, now we have our data, and now the data basically signifies that these are different things. Like, I have these fruits, and now comes a new fruit, which is being defined by this query vector. Now the goal is to see what this fruit is similar to. What is the other fruit that is the most similar to this query vector that stands for a fruit? Now here, we have not given it any name, like it doesn't have an apple, mango name. It's just the embeddings. And if you saw previously, the initial query that we had, it also had like it's red apple, green banana. So based on this query vector, it will tell us like the vector similarity cosine function, which majorly works with understanding cosine similarities between different images or different records. So this is basically how a search query would look like for any vector, most of them. Oof, again. I mean, what is this? Let me just see. Oof, thank God. Whew. So based on our vector search query, these are the two fruits that are most closest, most similar to the query vector that we've added. Now, this fruit could be any fruit that you do, but semantically, to understand more about this, these are the fruits that would come close to them. I hope vector search, the basic things what happen under the hood are clear to you. Now we move to the last and final stage of our talk, which is the whole thing that made me even applicable, oh my God, made me come to this conference. It's basically this conductor that is tying everything together. We saw Ollama, we saw vector stores, we saw vector search, we saw vector embeddings, we saw different models. But we need the conductor, right? We are in this theater and we want the conductor to like ask us to fit everything together, and that's where the star comes in, that is LangChain. So LangChain is this framework which is built in Python. It's built in Python, but what it basically does is it communicates between different components of your AI application to make sure that the data flows very well between them. It also makes sure that you have the memory management taken care of. There's context retrieval that happens from time to time. It has different prompt templates, and yeah, it's a whole black box if you want to get in. But in short, as an introduction, LangChain is a Python framework to build AI apps, and it does provide a lot of abstractions to like connect to different AI components. Now, if you go on the internet, you will understand that LangChain has around LangChain, there are a lot of opinions. Like some people hate it, some people don't love it at all. Some people are like, this is the way to future. So feel free to decide if you like LangChain. It does make things sometimes more complex, but come on, we're developers and who likes easy things? So finally, LangChain is majorly used in the Python ecosystem, and I would also recommend that if you love Python also. But it also has a JS SDK available, and if you want your application, which is not an AI application, built in JavaScript to stay in the same ecosystem, that's when using the LangChainJS SDK would make the most sense to you. Now, I have used the JS SDK, and with that SDK, I first built a vector store. Now, you could normally have a lot of vector stores already available on the LangChain's documentation, but I built a customized vector store for SurialDB with LangChain. You don't have to do all of that, but again, I wanted to do something crazy. And once the vector store is ready, the final piece of all of this is the word LangChain. It has this word chain. Why does it have that chain? Because what it is doing LangChain is trying to act like a human, where it's chaining responses, like it's chaining context. Like once the prompt comes in, it gets you the data from the vector store. But again, the data needs to be sent back for example, more computation or for more context. So the logic and the most magical thing that anybody should learn or study, I would recommend, is understanding how chaining works in LangChain. And this is just a small snippet of how the code for chaining happens. Like you retrieve the data from your vector store, then you put it into a prompt template. Now, again, I'm sorry, these are a lot of jargon words, but we have to get through last couple of minutes. And finally, when you have retrieved this data and you have put it into, for example, you've added your metadata to it, you can finally invoke the chain and add your question to it to get the most contextual answer for your question or for whatever you've built the AI application for. And the final demo for today. So, let us see. Please, God, please work, please work. But it should, yeah. So I am not going to run this again because that will, I'm not going to completely run this again because then that will show how Ollama can be slow at times. And if we are also used to fast applications. So I'm going to show through a series of commands that I have done and to give you the direct idea of what's happening here. So most of the logic is in, I hope this is visible, but it's a very, very, yes. So we already saw this vector store that I have built. Now, I know we don't push passwords and usernames, but come on, this is a demo app, and that's fine. Yeah, I wouldn't do that, and I'm a developer advocate, so I definitely shouldn't be doing it, but it's all okay. And so I have a couple of APIs that I've built. Some of them are to like upload documents because we have a lot of images going into. Then I have another API that basically converts them into embeddings. And then finally, I have an API to ask it questions. Like the chaining that we saw is to ask it a question. The first thing that we did here is, okay, I ran the SarialDB server so that it could be connected to the server. Let me see where it is. Yeah, so I first ran the SarialDB server. This is how you can start a server. I ran it in a memory mode. Next up, I went to, yes. Yeah, I uploaded some commands, which you can find in the upload sh document. Let me bring it up. Yeah, this. So all these photos that were there, I know, again, this is not the most best way of writing JavaScript, but so it's a curl command, sorry. But I've just added all the comments directly to my curl command. You would normally do it in a beautiful front end, but I'm not a front-end engineer, sorry. So I've just added all these commands, and finally, what you do is once they're uploaded, you can, again, have a post query that asks the question, which is, did the person visit a wedding recently? So the answer that it has come up with is based on the provided description of the image. It suggests that there's a possibility that the woman in the orange dress, let me just pull this up. Oof. I did not think this would be, okay. Yeah. The lady in the orange dress attended or was present at an event resembling a wedding. However, since this information comes from the context and not confirmed data, I definitely say she visited a wedding. I definitely cannot say that she visited a wedding recently. My answer would be speculative more than concrete or evidence. So it's getting there. Ollama is not the last final definition of having the most perfect applications, but it's getting there, and you can definitely build lightweight, easy AI applications that should keep your ashes to yourself and not make you scream it to people. And yeah, so that is what was all for today. If you want to read more about how you can download Ollama, how you can download LangChainJS, or you want to learn more about SarialDB, how you could create vector search, vector embeddings in SarialDB, all the links are here. And that's it from me today. Thank you so much.
Keep it going for Pratim!